Recently came across this Tektronix P5200A 50 megahertz high voltage differential probe, and it was tossed out as dead, and I thought, well, I don't have anything to lose, let's see if we can figure it out. Well, so what ended up happening is I did find a plug that would fit on the cable for it here, and these are supposed to take 9 volts DC. So I had my power supply set up to deliver 9 volts, and I thought, well, let's just see what happens. I tried powering it up, it beeped, and the lights here briefly lit up, and then it quit. And I mean, the tag it had said that it was dead, didn't mention any lights blinking. But I happened to notice that over here, and I don't have it powered up now because I took it apart, that it was pulling the maximum current this supply could put out, which was 5 amps, and it drew the supply voltage down to about 6.5. And you could feel the cable, this cable here, getting warm. So obviously something was shorted in there. So I thought, well, let's take it apart and see what we find. Well, that turned out to be easier said than done. Trying to get this apart, and I didn't know the trick. I mean, it seemed like there should be screws in it, and it wasn't glued around the perimeter, so much. Tried prying on it with, like a sharp knife here. Definitely seemed like there's something on the ends that was holding it together. But when you feel like if there's like a overlay or something, usually you can feel that there's like a divot there, and that's where the screws are. So I was feeling on that, couldn't feel anything. Thought, well, it's dead anyway, what do I got to lose? So I brought out my cutoff disc and tried carving into it to cut it open, and eventually I determined that there are screws. There's 2 screws here on each end, and the only way to get at them is to cut the... I didn't want to do it because this has got like a membrane switch on it, and so there's kind of a circuit board in there, and I didn't think there'd be screws under that, but it turns out there are on the end. So what I ended up doing is just slicing through the flex circuit on the very ends, and yes, there you can see 2 screws here, 2 screws there, so now I end up having these cut off pieces that if I get this fixed, it's not going to look very pretty after I put it back together. It's going to have a little Frankenstein stitching looking stuff to fix it. And you can see there's like a flex ribbon cable here that goes on to there's a connector right there. So it's not going to be pretty. And then I ended up cutting up the bottom end of the back side of it in chunks here. And now if I get it to work, yeah, I'm sure someone could argue that it's safety has been compromised, and I won't disagree with that, just because the case has been kind of carved up. But I guess for home use, I'm willing to take the risk if I can get it fixed. So at any rate, yeah, there's something shorted on here, and let's just get that out of the way. So a visual inspection shows that you got a cable here, and it has a signal output, which is a coax, and then the power is these thin wires, and I'm looking at this, and the very first thing that immediately pops out, see if I can get some better light on this, let's see here, is right here. This is cracked and burned. And then the other thing a person notices is on this EMI shield, there's a smoke stain or whatever you want to call it that would have been over the place where that is. So I took my meter, my continuity checker, because I had a suspicion here, And so the power wires come in on, there's two through holes where the wires are coming in. That's easy to follow. So I did some ohm measurements around here, and what this is a clamping diode in case you apply your 9 volts backwards. So if you did that, the 9 volts would be forward, you know, the 9 volts, the diode would be forward biased and clamp this and protect the circuit. So whatever power supply they were using, it might not have been the one that was supplied with this product, was capable of supplying enough current that it's burned up this diode. I mean, it definitely looks like a what is that? That's like an SMB size diode. What it looks like to me, SMB package diode. So yeah, I've traced it a little bit, and that part is definitely connected across the 2 power leads coming in, and you know, it's got about maybe 4 ohms resistance there, and you know, it should measure like a diode. So what I'm going to do is, I got my soldering iron warmed up over here, and we're gonna pull that part off there and see whether it clears that problem, and then if I can you know, maybe power this back up again, and you know, see if the thing actually powers up after the short is cleared. So that's what I'll do next, is I'm going to pull off that fried diode. Okay, I got the diode off of here. There it is right there. It was kind of annoying to remove. It didn't want to come off, and I ended up tearing off one of the 2 pads for it. The other one is actually the glue. The glue is let go off the board, so it's loose. However, I mean, I looked at this with the microscope, magnifying glass a little bit, and should be possible to kludge something in there to replace this diode, even if it's not the same package. At any rate, so I took the diode off. I've checked it. Shorts seem to be cleared. So then what I have done is I've plugged in the switch panel from the top cover again. And now we're going to let's see if it powers up now. And let's see, maybe what I'll do, let's turn this over so we can see there's LEDs underneath the dome switches on the overlay. And there's actually has a beeper in it as well. So let's turn this 9 volt power on and then see what happens. Okay, you heard it beep. The lights have stayed on, and it's pulling about a little over 300 milliamps at 9 volts right now. So it looks like well, something's working at least. Let's see if these switches work. This is like a range switch here. You can hear a relay clicking in there. Okay, so it looks like it powers up, and I need to sort of put it back together enough to see if it actually works properly. In order to do that, I'll have to you know, connect it up to a scope and put some voltages on these 2 inputs. This is a differential probe, so what it does is the difference between these 2 wires is what it uses, and this thing is like a 50 megahertz bandwidth, and these are often used, I'm sure this one was used for this, to look at floating high voltage measurements, you know, things like power supplies, motor drives, that kind of product, anywhere where you need to take a measurement of a relatively low voltage, but it's at some floating high voltage, or you couldn't ground your scope to the low voltage ground. All right, we'll see if we can partly reassemble this thing and then we'll see if it actually works properly. I'll probably end up taking, if that's true, I'll end up taking it apart again and trying to put something in to replace that diode, because it's not necessary for it to work, but it was there, and well, it turned out to be a sacrificial protection device. You know, if that hadn't have fried, I'm sure the whole board would have been fried. Alright, took me a little while to find some stuff that I could plug into these. These are shrouded bananas, and you need the right things to fit on them. So I found this chassis mount guy with a stripped end on it, and then there's this big gator clip that would fit on here. So I've connected both of those up to a separate bench supply, hooked it to a scope. So this is supposed to be 50x, and I'm on 100 millivolts per division. We'll just see what happens here. So I'm going to turn this supply on. I think the supply is set for about 30 volts, as I recall from some prior work I was doing. Okay, so the trace went off screen. Let's drop that down. So now we're at 200 millivolts per division. It's on 1x. We got 30 volts over here. So what does that work out to be? So if it's a 50x probe, if you got 30 volts going into it, if you take your 30 volts and you divide it by 50, let's just whip out the calculator here. 30 volts, alright, 50, and divide, and we should have 0.6 volts. So we're on 200 millivolts per division here. So it's 0.2, 0.4, 0.6. So exactly what you'd expect, at least on the 50x per division range. So seems like this probe is working after removing the fried diode. So if I switch this to 500x, I should get 1/10 of that value. So let's do that. Okay, and now it has dropped. Let's turn up as much as I could. We were at 20, so now we're at 20 millivolts, and we should get 60, and that's what we have. We have 60. Okay, so looks like this probe is nominally working, short of me trying to connect some AC signal into it. This is about as good of a check as I can do for right now. My guess is there really isn't anything wrong with the probe other than somebody applied the 9 volts in wrong polarity to it and blew up that diode. Alright, so I'm going to try figuring out how to kind of patch this thing back together. I put 2 of the screws in here just to kind of hold it together a little bit for this test. But yeah, there's all this metal shielding and what have you that has to go back in here, and then all the chopped up plastic that I'm going to have to figure out how to kind of, I don't know, glue that back together a little bit. Definitely wouldn't meet any normal Cal Lab specs anymore, of course, after all this carnage, but for home lab use, it might be just the thing you need once in a while. Alright, all for now.